Hello, students. I am working out of a new space that you might recognize. My background's a little bit different because I'm back in the building at KNDMS, and I know some of you might be back in the building as well, coming up in the end of February when seventh graders get phased in. Those of you that did opt to go back. For some of you, this will be some of our remote learning space. At that point, it is Miss Hibbard's old room. Hopefully we will get it set up for you in the next couple of weeks here. So that's why my background looks a little different. Anyway, for today, we're going to explore and see how molecules act in a phase change. We're kind of getting back into that. And you've seen 3 claims before, but we're going to try and eliminate some of those claims. We're going to try and pick out which one we think is right of the 3 claims that we've already seen last week. Part 1 was to reread this article. So you should have already done that. If not, you might want to go back and do that. So you should have already gone through this section of reading that article, answering those questions. And we're at this point here. So for this section, you're going to take a lot of time spending on each claim to figure out what do you think is supported or refuted. And the key thing here that I'm going to be looking for is, can you explain a piece of evidence from the article? Claim 1 is actually done for you. So you'll get a piece of evidence from the article that you just read, and you need to explain your reasoning that kind of would go in this avenue of the chart. You're not filling it into the chart. You'll just type it below the chart. And then you'll have another question that asks whether or not you think that claim is supported. So I'll give claim 1 as an example. Claim 1 is molecules in a substance disappear or no longer exist when a substance changes phase. Cool. The evidence that we use from the article is already put out there for you. It says no matter what phase water is in, the water molecules stay the same, they just move differently. Okay. You can explain that this matters if you have it already off the top of your head. If not, I highly recommend that you use the sim, which I'm copying and pasting out of here. It might just pop up as a link for you. So just go to a new tab, copy and paste. And that should take you to the sim. I'm also going to move my webcam up here a little bit. No, we'll just move me over here. And I have molecules in different phases. Substance A is one, substance B is another phase, substance C is another phase, so on and so forth. So if we play, it says click play to start. What I'm going to do is watch those molecules. That is in one phase. That's in a solid because they're just kind of moving in place. They're not really flowing around each other or trying to look like they're escaping from each other. So that's a solid phase. Now watch really closely as I change the phase on here. And again, we're looking at claim 1. We're thinking, did any of these molecules disappear during that phase change? Watch closely. Okay, did any of them disappear? I'm looking, I'm like, okay, no, they're just moving differently. So I go back over here and I see claim 1, molecules in a substance disappear or no longer exist when a substance changes phase. I don't think that's correct because, and the reasoning why is if water molecules always stay the same, then they cannot disappear when water changes phase. So that's my reasoning. And then the second question that I would ask you about this claim, I'm saying I refute claim 1. I think claim 1 is refuted. It is not supported. Okay, so you can use that phase change sim to help you out in your explanation when you go to like your long answer here for question 1 and as well as question 3, and then explain short and simple in questions 2 and 4 whether you think those claims are refuted or supported. So you're kind of doing that process for claim 2 and claim 3. Good luck, you can do it, and the next section will be your exit ticket.